Alright, I have given you video tutorial link on application of differential calculus in finding maximum and minimum point. And in today's class we are going to look at application of maxima and minima in real life. So let us look at this question. A rectangular frame is to be made from a piece of wire of 120 centimeter long. For what value of length will the rectangle have maximum area? So basically we have to find the length of the rectangle that is required to have a maximum area. Now if you look at this one, a piece of wire. So in order to make a rectangular frame from a piece of wire of 120 centimeter long, from this piece of 120 centimeter wire we are going to convert to a rectangular frame whose length we do not know and whose width we do not know. So let me say the length of the rectangle is x, and let me say the width of the rectangle is y. Now from this given information, what we will find is we'll find the perimeter of the rectangle. So since the length of the wire is just 120 centimeter, the perimeter of the rectangle is going to be equal to this length. So therefore the perimeter of the rectangle is going to be 120 equal to, how do you find perimeter of the rectangle? Is going to be 2x, it will give you length of these two sides, plus 2y. So this is the perimeter of the rectangle. Now here we have to apply, as per the question, we have to apply the maximum condition to the area of the rectangle. So therefore what we need here is we need the area of the rectangle. For now, as per this rectangle, the area of the rectangle is going to be x times y. So as per this question, what we are supposed to find is we are supposed to find the length of this rectangle. Now a is a function. This function a is being expressed in terms of x and y. Now normally the function, whenever you are given a function, the function, if I have to apply the maximum condition, the function can only be expressed in terms of one variable. Example like this: y is a function, and this function y is being expressed in terms of variable x. So you just have one variable, whereas in this area, function a area is being expressed in terms of two variables, x and y. So therefore we need to convert this equation something of this sort, where we have just one variable. So to convert, since the question is asking us to find the length x, we do not need this y. So basically what we can do is, this y we can express in terms of x, this y we can express in terms of x. So how do I express? So what I can do is I can simplify this equation. I can divide both sides by 2, so it becomes 60 minus x plus y, and this y can be written as y is going to be equal to 60. You take this x to that side, so it is going to be this one. So therefore your area is going to be x. This y I can express in terms of 60 minus x. So this is going to be the area. So what I have done basically here is I have expressed a in terms of one variable. Why I have expressed in terms of y one variable? Because I want to apply the condition of maxima so that I have the maximum area. Now what is the condition? Now here what we require is we need the area of the rectangle to be maximum. So the condition of the maximum is, in one of my video tutorial I have asked you to go through the condition of maxima. The condition of maxima is dx dy by dx equal to 0. This is first condition, and second condition is second order derivative is going to be less than 0 for maxima. So what we will do is we'll apply maxima condition to this area so that we can have the maximum area. So what we can do is, let us differentiate this area. So I can differentiate this one as dA by dx, and if I have to simplify this one, it can be 60x minus x square. So differentiating this one, I'll get this one, right? So I also need second order derivative. So let us find second order derivative. Second order derivative is going to be minus 2. Now what I can do is I can equate this one as per this condition to be, since dA by dx is equal to 0, it implies that 60 minus 2x is equal to 0. So from here what you're going to get is, you're going to get 30. So your x is 30. Your x, what is x? X is your length. So x is 30. So what I'll do now is, when x is 30, let us see what is going to be the area. And for that, what we have to do is we have to determine this maximum condition. So therefore what I can do is, actually I have to replace this x in this second order derivative. But here you don't find the x variable here, so you can simply write this one as less than 0. So it is satisfying the maximum, condition, right? So which means the area of the rectangle is going to be maximum when your x value is 30. So our conclusion here is, at x equal to 30, the area which is denoted by E is going to be let's say maximum. So as per the question we were supposed to find the length. So the length required is going to be 30 centimeter, so that your area of the rectangle is maximum. Thank you.